Good afternoon, year 10s. How's it going, guys? Sorry I'm a couple of minutes late. I'd put the washing machine on and I put it on thinking that I put it on at just the right time. So it'd be finishing when I'd be starting. I don't know, it was 2 minutes long. So it's all good. It's just finished. It's amazing. The register's nearly done. We're just missing 3 people. We're missing Nick, Toby, and Ben. That's what we're missing. That's it. Everyone else is in and registered, which is amazing. So just need Nick, Toby, and Ben to make an appearance. Come on, guys. Like I said, you know what? I can't really. I thought I was playing really, can I? Because I was late myself. So it's okay. Let's give them a little bit of time. How is everybody? Is everyone okay? Hey, there's Ben and Nick. Look at this. Nearly there. Ben and Nick. Just Toby missing. Oh, I hate it when Toby's late. We share a name and just come on, Toby. Where's Toby? Somebody send Toby a message. Somebody send Toby a message saying, Toby's waiting for you. Oh, it's funny. How is everybody? Is everyone okay? We're nearly at the end of the day. Only 2 more lessons. Come on. We are sending him a message. Thanks, Rue. You're a hero. Good job. There's Toby. Toby, we're waiting for you. There you go. Why did Toby then laugh? Oh. Anyway, we're all in. Look at that. Boom. Full house. Full house. Yeah. Chemistry dance. Right. Okay, guys. So now that calculations are done, we are done with calculations. We're now moving on to our new topic. So, sorry I'm late. Don't worry about it, Toby. It's fine. Okay, guys. So today's lesson is right there. There you go, folks. Get your title and your learning objectives in. I like it. So today we're starting our next topic, which is acid-base theory. So we're moving on from calculations. Calculations, of course, never end. They're in everything. Yeah, and you know the great thing is, of course, in acid-base theory, this is all about solutions. Yeah, which means, so this is just a quick nota bene straight off the bat. Yeah, straight away, nota bene. Yeah, nota bene for acid-base theory. Yeah, we're going to be using number of moles equals C times V over 1,000. This is moles in solution, of course. This is going to be making a big appearance throughout acid-base. Moles in solution. Chemistry has all the solutions. see what I did there? Oh no, I shouldn't have done it. I'm going to put that in a box. I'm going to put that in a bubble. In a boobler. Put it in a spangly bubble. Woo, yeah. So this will be used in acid-base theory later on. But first of all, our learning objectives today, folks. So we're going to be looking over 3 learning objectives. Number 1, first thing I need to do, guys, you haven't looked at acid-base theory since year 7. Yes, that's right. And it's been a long time. And the first thing we've got to do is just recap all of the key stage 3 acid and base stuff that you guys did. Sorry, got a fly in the throat. So we need to recap key stage 3 acid base. That's job number 1. Write down all the key facts that we're going to need. The second one is we need to know the important acids and bases. Now, I've been doing that with you guys for a while now. So this one is just, again, it's always lovely to realize just how connective chemistry is. All the topics tied together, obviously calculations ties in, and we've been doing just general reactions, and we've already done some of those acid-base reactions and knowing the rules of them. You know, metal plus acid goes to salt and hydrogen, metal oxide or hydroxide plus acid goes to salt and water, metal carbonate plus acid goes to salt, water, and CO2. We've already covered that. But that's all part and parcel of this topic. So you get a good bit of reinforcement. And my final learning objective, which is really my aim, is I want you guys to understand the term dissociation, or otherwise known as ionization sometimes. but the dissociation of acids and bases. So we'll talk about that today. Okay, so I think the first thing we need to do is we need to box off key stage 3. Yeah, so subtitle, guys, I'm going to leave the learning objectives there. Key stage 3, acid-base theory. I'll put acids and, by the way, okay, first thing I need to mention is this nightmare. Acid alkalis. Yeah, so can I just point out that it's really common for this to be given as that topic title. I don't know why they do it. I have no idea. It doesn't, the only similarity here are the 2 A's. Yeah. And I don't know, acids and alkali rolls off the tongue, maybe? I don't know. But the first thing I need you guys to realize is that this is not a good term. Yeah. What this should be, I'm making the very first correction here, guys. Yeah. It should be acid-base theory. Yeah. I'm going to capitalize this. So I'm going to change my color back to black. Yeah, we shouldn't call it acids and alkalis, but we do. Yeah, I don't, by the way, I don't teach acid and alkalis. I teach acids and bases. Yeah, because the first thing we need to realize is that in chemistry, now there are many families and many topics and many bits to chemistry, but what you learn is that there are particular families, yeah? And the acids and bases are a family. And in that family, there are 2. So we've got the acid family, and we have the base family, yeah? So acids and bases are the opposites of each other, yeah? Now, so where does the word alkali come from? The reason being is there is a subset of bases, yeah, which are alkalis. Alkalis. There you go. So now that's what always frustrates me, because I think what most people will now realize is all alkalis are bases, but not, oh, actually, no, I want it. But not all alkalis are bases, but not all bases are alkalis. So the question is, onto the chat, see how many people of you guys remember this from year 7. Yeah. So the question is, what's the difference? What makes an alkali an alkali? One word. That's all I want. Yeah, what makes a particular base an alkali? Let's see who replies on the chat. pH. Kieran's got it. Thank you very much, Tom. Nothing to do with pH. Doesn't even make sense. So alkalis and bases, the alkalis are pH. Doesn't make any sense. Well done, Kieran. They're soluble in water. I just wanted the word soluble. They're soluble. Yeah. So we need to look at examples of these now. I've just suddenly realized I wrote down properties. I don't want it anymore. Yeah. So realizing that, in fact, here's the frustrating thing. Most bases are actually not soluble in water. There's just a select few of them that are. So just to show you an example, yeah, just to write down and go, right, what are the bases and what are the alkalis? Yeah, key things here is, if I go sodium hydroxide, the most famous of all the bases, yeah, that is also an alkali because it's soluble in water. Yeah, and if I then go for any group 1, potassium hydroxide is also, all the group 1 hydroxides are all soluble. So they're all classed as alkalis. Yeah. However, we then get to more important ones. Things like limestone. Limestone is a base, but it's not soluble. So it's a base, but not an alkali. And that one you need to know. If I'm gonna too fat. Yeah, this one you need to know about. Need to know him, need to know him. Dead important ones. Important bases to know. Okay, so I've cleared up the issue of acids and bases, and we're no longer going to call anything alkalis. Yeah, you're just going to call everything a base, but there may be the question in your GCSE exam of what's the what makes an alkali different from a standard base? And you say because it's soluble in water. Yeah, if you want to add that question to your notes, feel free to do so. Yeah, but it's a question in an exam, and you shouldn't really use that term because you could be wrong. Yeah, more bases are insoluble than soluble ones. So anyway, so now that we've got these two families, we've mentioned the two families, acids and bases, we now need to kind of define them a little bit. So what makes an acid an acid? And some people really don't like this part of the lesson. So an acid, how do you know if a substance is an acid? Yeah, question. How do you know an acid is, shouldn't do that. How do you know a substance is an acid? Question mark. The answer is it reacts with a base. Reacts with a base. Isn't that funny? I got all kinds of funny questions on the chat with the other class about that. They were like, oh, I don't like that. How can you say that the definition of an acid is that it reacts with a base? It's not really the definition, and I'll come to the definition in a minute. But that's one of the things that you need to know. Yeah. If a substance reacts with an acid, it is a base. If a substance reacts with a base, it is an acid. Yeah. Did I say it the right way around? If a substance reacts with an acid, it's a base. If a substance reacts with a base, it's an acid. Yeah. That's kind of one of the ways in how you tell. Okay. So next facts that we need to pick up facts here, don't we? Now, the thing is, I've got to be careful. I'm not trying to go into the GCSE theory here yet. I just want to round up the year 7 stuff. Yeah, before I go any further. Okay, so now that we recognize the two categories, what we now need to do is do common acids and bases to learn. Yeah, we're going to need these. Learn. Love a good learn. There we go. Common acids and bases to learn. So in chemistry, there are times when it's just having that kind of knowledge base there is so important. Do I still have everyone here? Everyone's been very quiet on the chat since they arrived. I guess you guys are trying to keep up with me or with your note taking. I do apologize. If you want me to slow down, just let me know. Yeah, so let's do the acids first. Acids. That does not look like acids. Writing's not very good today. Acids. Right, guys, we exist. Love it. Okay, guys, so on the chat, please. I want as many of you to contribute as possible. Yeah. Or do we? Oh. Can you put on an acid onto the chat that I can add to my notes, please? All of you, please, just throw in the name or formula of an acid. Nitric. Thanks, Rooming. So Rooming's just thrown in nitric, HNO3. HNO3, nitric, like it. Nitric acid. Can I just point out, Rue, I really love that you chose that one. Nitric acid is probably the most forgotten of the acids. Hydrochloric, thanks, Ruby. You're a star. HCl, hydrochloric. Love it. Shanley's in there with sulfuric, spelt incorrectly, but it's okay. Hydrochloric acid and sulfur with an F, sulfuric acid, H2SO4. Oh, look at Isabel. Oh, Isabel pulling out a big gun there. Oh, Toby, phosphoric, H3PO4. Phosphoric acid. That's a great one. And Isabel pulling out hydrofluoric there. HF. Well done. Hydrofluoric acid. Nasty, nasty, nasty stuff. Scary stuff. Carbonic. Ben, Shan, did you just throw me sodium hydroxide as an acid? Is that what you just did? After our conversation up here about alkalis and bases? Sulfur. Ooh, got to be careful with Kieran giving me that one. Carbonic. Thank you, Ben. H2CO3. Carbonic acid. Wow, I love it. It's a great one. Stops making the oceans more acidic. Kieran's gone and thrown in one I don't like. Ethanoic. Anna, well done. That's great. Right. Oh, I don't like it, Kieran. H2SO3. Sulfurous. Kieran, I don't like it because I spend a lot of time trying to persuade students not to know that. Why? Because it never comes up in any exam questions. You get it at A-level, but not at GCSE. It's what you get when you mix SO2 with water. It's what actually acid rain is. Sorry, H2O. This is actual acid rain. But the thing is, it's not sulfuric, and sulfuric is the one that is phosphorus. Now, phosphorus is an element, Kieran. Phosphoric is not as bad as the others. It's actually a weak acid, annoyingly. It's an unusual, it's a mineral acid that's weak. It's very unusual. I do want, by the way, Anna's, though. Oh, Anna, yours is outstanding. Ethanoic acid. Well done. God, do you know what? I love the fact that you guys have got such a great knowledge base. God, look at that. I want to add more to it, though. There's a few others I want in there. What about HBr? Can someone give me the name of that one, please? On the chat. Give me the name of. Rooming, we've already had sulfuric. I know that. Moses gave me sulfuric. Oh, sorry. Moses was the one that gave me sulfuric. Oh, Shan did as well, but both spelt it wrong. Yeah. What about methanoic? Ashley, well done. Hydrobromide, no. Rue, hydrogen bromide, hydrogen bromide would be the name of HBr as a gas, but that there as aqueous, we'll come into that soon, is hydrobromic acid. Who got it? Someone did? Yeah, look at that. Toby and Tong. Yes, well done. Ashley, love your methanoic. Methanoic is one of the ones at A-level which causes people right trouble. Methanoic acid. Love it. Look at that. What a list. Guys, I'm super impressed. Now, you'll notice that I've been giving you the formula and you've been spitting out the names. The formula, of course, is slightly harder. And it is worthwhile learning them. I'd love people to make some revision cards for those. They'd be great. I'm now going to flag up the ones that you really need. Yeah, I'm going to star them. So I need you guys to make sure you know nitric, make sure you know hydrochloric, sulfuric, of course. You can skip, phosphoric does appear. I'm going to put that one over here. You need that one for the end of GCSE. It's the catalyst for making, catalyst for direct hydration. That's what that's for. That one is a catalyst. You don't need to know the formula, but the name you do. You don't need hydrofluoric. It's nice to know carbonic, although never really appears in exams. Ethanoic, you do know. You must know ethanoic. Yeah, you don't need methanoic and you don't need hydrobromic. So you've got 5 acids there that you really should recognize, and definitely ones that we need to make sure that we've practiced and learned, and I'll do a lot of that over the next coming weeks. Okay, now that was really fun. That was great. And can I just point out, I'm really impressed. What we now need to do, folks, is the bases. This is going to be very interesting. I clearly have harped on about the acids to you guys over the last year or so. Can someone now on the chat, guys, give me my bases, please? Give me my bases. It's the bases song, big hit in the 60s. Yeah. Go on, guys, come on. Give me some bases. Drop the bass, guys. Oh, oh, thanks, Rue. Rue's first in the house. Sodium hydroxide, NaOH, KOH, I like it. Yep, all of these needed. Yep. Sodium hydroxide. It's interesting. I flipped. Oh, no, I haven't actually. Yet. Sodium hydroxide. This is going to be a fun game, this one, to see what you guys do. Potassium hydroxide, gone Yorkshire. Hello. Hydroxide. Next. Oh, had some good ones, Ammonia, well done. Rubidium hydroxide, barium hydroxide, calcium carbonate, well done, Ashley. Guys, all correct, all good. Lithium hydroxide, I'm struggling to keep up with the names. Lithium hydroxide. Next, I love the fact that Tong has just given me ammonium hydroxide. I love that, Tong. That's really, really cool, actually. I mean, it's quite unusual. It's not something I usually get from students. I'm trying to delete this rubbish. Go away, stupid keyboard. Oh, no, you guys are going to add more, aren't you? Ammonium hydroxide. Ammonium hydroxide. Well done. Ammonium hydroxide. Great job. Spot on. I'm actually going to do something funny now, guys. You guys actually, annoyingly, you guys don't need to know. So I love that, Shanley. Strontium. It's amazing. It's actually correct, Shan. Isn't that hilarious? Just put ammonia and ammonium hydroxide together. Yeah, ammonia. Now, the great thing is in terms of acid base, you guys actually don't need to know the distinction between these two. Yeah, which is quite nice. These are both bases and in reality kind of the same thing. Yeah. We're doing really well. By the way, everyone so far that I've put on my board are all soluble. Oh, look at that. And isn't that funny? Calcium hydroxide, great job. Who did calcium hydroxide? Toby, well done. Calcium hydroxide. Now, this one's your first one of interest. Calcium hydroxide. It's used in lime water. Yeah, that's actually, if it's aqueous, it's lime water. Yeah, but this one's a funny one because actually it's only partially soluble. So it's interesting that, isn't it? It's like on the boundary between an alkali and a base. It's always a base, of course, but it's only a very mild alkali because it's not very soluble. Ammonia is else is on there. Kieran, rubidium hydroxide, absolutely. I've never seen it. That would be a very expensive chemical to make. Rubidium is more expensive than gold. So that would be a very expensive thing to make. Yeah, rubidium, absolutely, it is correct. Rubidium hydroxide. Rubidium hydroxide. Barium hydroxide, calcium carbonate, yeah. Barium hydroxide, I'm going to skip barium hydroxide, don't really care about it. I'm going to put calcium carbonate, that one's important. Calcium limestone, calcium carbonate. Try and do a Welsh accent. The problem is when I do a Welsh, I seem to go very high. So calcium carbonate, strontium. I'm not very good at strontium. SR, strontium. I think it is. Strontium. Now, it's actually just point out strontium metal. Right. Strontium hydroxide, absolutely. Only really RIP. Oh, really RIP. What the barium hydroxide? I'll put the barium hydroxide on. It's correct. It is. By the way, barium hydroxide is full on lethal. Yeah, that stuff's terrifyingly toxic. Like scary toxic. Scary. Barium hydroxide. I like it. And the great thing is about this game, I love the fact that I've then got copper hydroxide. Harris, I love your answer. Can you give me the Roman numeral, please? Give me the Roman numeral, Harris. If you ever use a transition metal, no, wrong number, you guessed. If you ever, yeah, it's 2. Yeah, Harris, if you're ever guessing, choose two. It's probably more likely going to be the right answer. Acetone, Shanley, no. Acetone is neither an acid nor a base. Good one, though. Yeah, it's a solvent of stuff. Yeah, acetone is neither acid or base. Look at that. So, guys, what I'm hoping that you guys are doing, by the way, I'm also going to say metals. Yeah. Pretty much all metals, apart from the noble metals like platinum and gold, and even those technically can act as bases. They can react with crazy acids. But metals are bases. They will react with acids to produce their salt and hydrogen. So metals are good bases in general. Yeah, iron reacts with acids. All the group ones react with water. Yeah, all the metals are bases. Wow. Okay. Now the problem is this is now going to become out, and the metals are going to cause me a reach trouble. Now what we need to do is I need to ask you, do you know what? I've got a couple of things I actually want to do at the minute. Hang on a sec. Ooh, on the chat, year 10, are you ready? Can I please have the flame test for sodium hydroxide? The flame test. Off you go, give me the color, quick please. Quick. What would be the color of the flame if I flame tested sodium hydroxide, please? First person on the chat. Who's going to be first person on the chat? I'll give a commendation for the first person on the chat with the correct color. Come on. Red. No. Toby's in the house. Kieran, learn your colors. Like, how can I just have had, oh my lord, I'm fuming. I've just had Kieran and Roomin give me red. Shame on you. And Ruby giving me lilac. Ugh. Furious. I'm livid. It would be sun yellow sodium. Come on, folks. Toby nailed it. Thank you. Next, what is the color going to be for potassium hydroxide, please? Who's going to be first in the house? Ruby is one chemical too early. I know, right? Lilac. Thank you. Kieran, learn your colors. Yeah, it's lilac. Yeah, lilac color. There you go. What's going to be? Go on. Come on, guys. Give me the next one. Lithium. Who's going to give me lithiums? I was too far ahead. Yeah, whatever, Roo. Thank you very much. It is red indeed. A beautiful red. Beautiful. It's one of my favorites, that one. So it's a gorgeous red. Next, are you ready? What color am I going to get? I love this. This is a great game. What color am I going to get for calcium hydroxide, please? Come on. Come on. Who's going to get the next one? Orange red. Toby is on it. Ashley, well done. Shanley, well done. Good job. Kieran, oh yeah. Kieran, you haven't learnt it. Come on, dude. You're better than this. Come on. Well better than this. Sheesh kebab. Okay, next. So that one is orange red. I was really hoping that someone was going to say brick red to me. It's fine. I don't know what I want to do it anyway. It's not like it's the one that I learned. It's orange red. There you go. It's orange red. Yeah, is the right answer. Next one. Oh, rubidium. I've never taught it to you. See, there are ones that you don't need to know this one, folks. Rubidium's purple. Just so you know. Rubidium, purple. It's purple. Yeah, slightly darker than the lithium. Superpowers. How does Toby type superpowers? I know, right? Skills. Seriously. Can anyone remember strontium? Who can give me the color of strontium, please? Come on, folks. Come on. Imagine if rubidium was ruby red. Yeah, no. Well done, Ruby. You star. Strontium is a very similar red to lithium. I'm really impressed, young lady. Really impressed. It's actually darker than lithium. It's got like it's just it is darker. I'm going to show you what it really looks. And that's, you know what? Actually, it is that color. Yeah, it's darker. The other red is very red. Lithium is crimson red, but strontium is a darker red. Yeah. Can anyone tell me what barium hydroxide would be? What's the color of barium? What's the color of barium? I can't believe I'm singing this. I have lost my marbles. It is, oh, Kieran, pulling it out the bag. Kieran, I'm going to let you off. It is indeed apple green. Yeah. By the way, if you were to describe it, you'd call it a yellow green. Yeah. There you go. It's a yellow green. I think they would actually accept green. Oh, and there's copper. Can someone give me the color, please? The copper. Come on, guys. Wonderful singing. Oh my god. Yeah, I'm real. Do you know what? I do sometimes forget. I do sometimes forget I'm doing this, and it's very embarrassing. Anita, go! That's amazing. I can't even remember how Anita starts. I think you actually mean like the person from the from West Side Story, right? Blue green, well done, great job. Ben was in there first with blue green, Ashley in second, Tong, Ruby, Shanley. Oh, but if heated enough, turquoise. No, if you heat it hot enough, it turns blue. It's green, really. Puerto Rico. Oh my goodness. Shanley, I'm not posting You Ugly Island on there. I'm not doing it. Crazy. Blue green is the right answer. It is indeed blue green. Yeah, blue. But in reality, can I just say, actually, it's more green than blue. It's blue green. Yeah, but it is easy. Yeah, anyway. Anyway. What did Vic retract? No, that's the next line of the song. What? Is it? Anyway, it's nice to remind of ourselves of our thankfulness. How lovely. That was fun, wasn't it? Wasn't that fun? Really enjoyed that. Anyway, moving on. So, bases to learn, folks. Let's star the bases you've got to know. You got to know him. Yeah, got to know him. Got to know him. Got to know him. They're easy. They're just group one metals. They just switch them around. Easy pie. Easy pie. Got to know that one. Got to know ammonia. Don't really need to know ammonia hydroxide, but it's good to know it. And you need to know calcium carbonate, and that's it. That's it. That's it. There you go. 6. How many acids were there? 5 acids, 6 bases. Got to know them. Got to know them. West Side Story parody book chemistry. It was, wasn't it? That's exactly what it was. I know. I am amazing, Victoria. I know. You don't have to tell me. Anyway, so back to here. Right. So at this point, I do now want. We continue with the year 7 stuff. I'm realizing I'm going to get nowhere on my learning objectives. Yeah, I'm going to end up doing only the key stage 3 stuff. Although no, we've done important ones. We've done that one. Whoop, whoop. Yeah, done that one. Boss. Okay. Next. Now what we need to talk about is the pH scale. Yeah. pH scale. So what I want you guys, I'm hoping that you guys have already realized this by now. Yeah, what does the pH stand for? It actually stands for potential for hydrogen ions. And that's why it's a capital H. I'm sure that there'll be people in the room who are like, holy moly. See, moles appearing there again. There's so many times I've been teaching kids and they write down pH and they write down the small p and the capital H and they never bother to ask. Yeah, they don't even notice they're doing it. They're just like, what? It stands for hydrogen. Yeah, it's the element's symbol, potential for hydrogen ions. Mind blown, I love it. So we now know, now here's the next bit, guys. year 10. I'm going back to my screen. Right, we need to have a chat. We need to have a quick chat. I just want to point out, number one, I didn't teach you in year 7. I didn't teach you. Number two, we lied. The pH scale is a bit of a nightmare. In year 7, now I'm actually going to say, I love the fact that point number 1 was that I didn't teach you. And then I'm now going to tell you that I lied to my year 7s too. But don't tell them. The pH scale I teach in year 7. I teach sad face. I teach in year 7 that the pH scale goes from 1 to 14. That's what I teach. Now there's a reason for this, because we say low numbers, 1, we've got low numbers are acids. 7, they might be watching this vid. Nah, they won't. So the low numbers are the acids, and the high numbers are the alkalis. The dead in the middle is 7 being neutral. Yeah, we teach this. Yeah. So the reason why I do 1 to 14 is because those numbers are very easily understandable for the students. Now, every now and again, you come across 0 to 14. Now, I don't teach 0 to 14 to my year 7s because some of them really struggle with the content, the concept of 0. They struggle to think that if an acid has a pH of 0, then it would be more acidic than something with a pH of 1. They don't like that concept. It's just the number 0 in year 7 they struggle with. So then what tends to happen is I then tend to go with GCSE. All right, guys, 0 to 14. Eh? It's a bit of a lie too. Sorry, guys, you don't need to know this, but the other year 10 class got very upset with me, and they started throwing around accusations of lying, and I was like, So I'm just gonna be honest with you. You can get negative pH. You can laugh my ass off. And then Shani said, oof. You can go down to about, so the range really goes from about minus 1.5 to 14.5. Those are the max limits. Yeah, leave it at that. Cool beans. Amazing. Yes. Just leave it at that. So, wow, pH makes me feel like year 7. Oh, great. Amazing. Cool. Right. So, however, you guys are still GCSE. So, can we just stick with 0, please? Because, because 0 didn't really make it confusing. I know, yeah, but the year 7 struggled with the concept of 0, that's what we're showing. That's it. Right, let's go back to sharing the screen and write down some information. How many other lies have there been told by the council besides the previous lie? Rue, that I'm not lying to you. I'm just not giving you the full picture. That's all. I'm not lying. I teach 95% real chemistry and 5% like omission. No, but it's not like lying by conspiracy theory. No. Moving on. So we know the pH scale. We remember this. Yeah, and we know it goes from 0 now to 14. Yeah, 5% is so much. We learned it in history. History knows nothing. History knows nothing. So every 100 sentences you say, 5 of them are lies. No, Ben, this is what happens. I should just lie to you guys instead of telling you stuff. Darn you, year 10. It's only because I like you. So we remember from year 7. 7. Yeah, and then we get 1. Do you know what? I'm not gonna draw it. I'm gonna cheat. You guys can too. You can too. Big brain. Let's go to here and go pH scale. Yay! We love the pH scale in year 7. It's just all the fun practicals and mixing stuff to make colors. It literally is like the kids' favorite practical ever. Yeah, there we go. Look, it goes from, look, there we go. It goes from 1, and then some go from 0. Nah. But in reality, we all know. Anyway, I'll stop talking. So, just a quick picture I'll paste in there. There we go. So, you guys remember all this stuff from year 7? You remember all the cool pictures? Darn it, don't let me do that. Move, will you? Become big. There we go. Okay, pH scale. We remember all this stuff. Yeah. And you guys remember, we can no longer trust you. Change sentences to words. I don't, you guys are mean. You can trust me. So, we know, we got taught in year 7, yeah, that between here and here, yeah, between 1 and 3, yeah, it's kind of telling me what you get, yeah. You get told that these are strong acids and that these then become weak acids. That's a lie, total lie. Yeah, there's neutral in the middle. And then you get told, kind of to 11 really, these are weak bases and these are strong bases. That's a total lie. Delete, 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 delete. It is not how the game works. But you do need the colors. Yeah, we do need the colors. You guys do need to know that if you add, a strong acid will turn red. We still need this for GCSE. Strong acids, yeah, strong acids with universal indicator, with universal, which is where all the colors come from, indicator. Yeah, strong acids go red. We know this. Yeah, we all know this. Yeah, and then we know that the weak acids, by the way, this is actually more problematic. Yeah, lies again. I know even this is now tricky, to be fair. Weak acids, we would tend to say with universal indicator, yeah, we would tend to say turn orange or yellow. This is, again, not as clear cut as we would like to think it would be, but you need it for GCSE. You need to know that neutral is green. Yeah, you need to know that neutral with universal indicator is green. You need to know this. Yeah, you need to know that ammonia, this one is the one that comes up specifically in exams. Yeah, that a weak alkali, a weak base with universal indicator is going to go blue. Yeah, we remember all this stuff. Remember all of these things from GCSE, they go blue. And then a strong base, you've got to know for GCSE. Strong base, by the way, there's your ammonia as a weak base. Yeah, deceit. And then a strong base like sodium hydroxide. Yeah, any OH we know is going to go purple. You do need all of these things for GCSE. They are not gone, they are kept. We need them. So the pH scale, you need to be able to give these rough numbers that go with the colors, and that's about it. That's all you need to be able to do. Okay. Other things that we need to do from year 7. I think actually that's about it. You do need to be able to name which ones, and I'm going to start giving you some of these. So, okay. Other facts. I realized that the lesson's only got 10 minutes left. So, other facts that we need from year 7. Yeah. Number 1, yeah, acid plus base. Yeah. This reaction is called, can anyone remember? Blank. Fill in the blank for me on the chat. Number 2. I'm just gonna, yeah, there we go. Reaction is called blank. Next, we do need neutralization. Thank you, Booming. Neutralization. Other facts from year 7 that you get: household acids. such as vinegar. Vinegar is a weak acid because it's ethanoic. Ethanoic is a weak acid, hence why we can drink it. Battery acid, because every now and again they bring these up again. It baffles me. Battery acid, by the way, which is otherwise known as sulfuric. Yeah, what they said. Love that. Neutralization, neutralization, neutralization. Great job, guys. Thank you for remembering. Yeah, battery acid is strong. By the way, battery acid is sulfuric most of the time. Yeah, these are strong. So that kind of pretty much brings you to the end of year 7. And with year 7, you're doing all of the various mixing things around. And I can kind of call it at that point. So I do want to say we have recalled what you did in year 7. We haven't done this learning objective. I will start that next lesson. I think I'm actually gonna leave you guys be at this point. I don't think there's any point. I'm tempted to do no, I think I'm just gonna leave it there today. Just gonna leave it there. You guys have already accused me enough of lying, so I feel like I need to abandon you as quick as possible. Guys, next lesson, I'll begin the GCSE stuff. We will look at dissociation and what actually makes an acid and a base a base. Actually, you know what? I can do that now. Oh, Rue, don't give me a sad face. Hang on, I will add that in actually. Yeah, I do want to quickly mention. I do want to do a little bit of the GCSE bit. One tiny thing. So the question is, what are acids? Yeah, what is similar? Okay, I'm gonna go to our list. Loved our list. Which element is similar to is the same in all of those? Which element is contained in all of them? And you realize, of course, it ties into pH. Hydrogen. So that's correct. Thanks, Rue. So acids. What we learn is that in order to be an acid, you need to be able to lose H+. That there, the hydrogen ion, is what makes an acid an acid. This is what, when you pour it onto your skin, this is what burns you. Oh, properties. Missed it. Yeah. Properties of acids and bases. Properties of acid and bases. There's 2 properties, and that's it. That's all you need to know. Number 1 is they are irritants. Irritants when dilute. When dilute, meaning in lots of water, drowned in water. Yeah, when they are dilute. And corrosive when concentrated. When concentrated, so like, no water. Concentrated. Yeah. So acids, if you see this now, this is what I need you guys to do. You see H+, and you go, acid! That's what you need to think. And it needs to be like that in your head. You need to hear my horrendous screams. Yeah, when you see that in your exam and you just go, oh my God, that's an acid. Where's the acid? Yeah, that's what it's telling us. Yeah. So if an acid, let's look at HCl then. So HCl, yeah, when HCl reacts with a base, what it's actually doing is it's giving away H+ to it. How would bases be defined? Okay, so we actually say they lose H+, but we would actually say, and this is the more important bit, and annoyingly, they lose H+, but acids, I want you to write this down instead, acids donate, are proton donors. I need to explain proton. So, proton donors, they give away H+. H+ is simply a proton, because a hydrogen atom, an atom of hydrogen is a proton and an electron buzzing around it. If you take away, if we do a hydrogen ion, it loses its electron and just becomes a proton. As being able to gain H+. Yes, that's correct. So acids are proton donors and bases are proton acceptors. Proton acceptor. I'll show you. So HCl, we know what part of HCl makes it an acid? H+. Let's react that with sodium hydroxide. Can anyone guess which part of the sodium hydroxide makes it an alkali? Look at your family. Look at them. Which bit makes it an alkali? You can see it everywhere. It's in most of them. It's the OH. Thank you, Rue. It's the OH minus. Yeah, a base is OH minus. That is what makes an alkali an alkali. Guys, what do opposite charges do? What do opposite charges do, folks? Come on. I love that. I think attract. Thank you. And what's going to happen when these guys collide? What are they going to become? You can see it. You can see it in the chemistry. There's something beautiful about being able to see it. I hate my slow typing skills. It's amazing. Well done, Ashley. Well done, Rue. Well done, Kieran. We're going to form water. And that's what neutralization does. The acid of H+ reacts with the base in OH minus and becomes neutral water. What about the bases with no OH? I knew that tends to happen, Kieran. That question tends to appear. I'm going to form water and salt, by the way. Yeah. Kieran's asked a very good question. What about the ones that haven't? So they can also accept. So, all right. The reason being is the H+ is really just looking for electrons, Kieran. It desperately wants electrons. It will take electrons from whoever it contacts. We know that metals like to lose electrons. This is why they can act as bases. The hydrogen will steal them and they'll become the metal positive ions. Yeah? The calcium carbonate, the carbonate ion is a negative ion. It's -2. It's got more than enough electrons. It will give electrons to the H+. The H+ will turn into water and the CO3 2- ion will become carbon dioxide. Yeah. So it's really the H+ looking for electrons, but we always talk about this proton swapping and this proton exchanging, this proton donating and losing, and it's just the way we always talk about things in acid base theory. There is another picture. When you get to A level, you then talk about Lewis acid base theory, which is all about electrons. But I mean, I can do that with you now. It's not a problem. But yeah, and that brings me to the end of my lesson. Holy moly, it is the end of the lesson. You guys are going to be late for your next lesson. I'm so sorry. Guys, it is the end of the lesson. You're going to be late. Guys, go. Have a great rest of the day, and I'll see you guys very soon. Next lesson. You have no homework. Woo! Have a great day, guys. See you later.